Yeah, so let me just go ahead and share my screen and boom. So this is the one that you are talking about here. Yeah, so it looks like this guy's doing a lot of stuff here. He's working on the same project that we're working on. And so he has his problem statement, the libraries, data set, and then he did an analysis on all this stuff. So yeah, we created the distance. We were thinking about creating the speed as well. Um, he created
So
some
he
other ones.
broke that entire date time into like hours, weeks, months, and timestamp. And he
Down.
was analyzing that entire date time into like the hours, like what hours basically the number of trips are, what weekdays, what months he did that.
Mm-hmm.
So trip duration per hour, trip duration per weekday, trip duration per month. And you
Yeah.
can see this bivariate analysis which he did.
Hmm. Yeah, I see that. And then he did multiple map visualizations as well.
Yeah, he used matplotlib for map visualization, not Folium and all.
And then he used multiple models as well.
Mm. Multiple linear regression, banding, forced regression, XGBoost, regressor. Wow.
I mean, model is I feel like that's I am like I'm always like concerned about not I'm never concerned about the model. I'm more concerned about like just the EDA. And because if
Idea?
EDA is good, like you can try using any model, you won't get like really bad results. But if the EDA itself is messed up, like if we are not able to get the right features and like the like the correct if we are not able to remove the outliers and right features, then like irrespective of what you use the model, like it is going to not give you better results. That's what I think. So I feel like EDA is something which need to be like worked on a lot, and that's what I'm always like concerned, and that's what I want to learn actually, because I'm not good at understanding EDA and what techniques you need to use and what exactly you need to, because I knew like box plot is something which gives you like a variance and understand the data better, but still I want to understand why exactly you use it, when you use it through this data set. So that's what like I'm focused on.
Mm. Okay.
Yeah. I wonder how you add this, just like the links in the beginning, because this is probably. I like how he built this. It's very clear. And then it looks like he just took the time before even doing it. At least it feels like that. Just looking at the table of contents, like he thought about like what features can I add. It's almost like a brainstorming session. Like let's create as many possible features as we can. That's what it seems like.
Yeah. What up, guys? How are you?
Hey.
I would, yeah, I would say so too. I mean, at least 20% of it. 20% of the work was already planned in the beginning. So
Yeah.
you can imagine him doing some manipulations, some edit. Yeah.
So what are you suggesting, Aditya? As far as you want to follow his Jupyter notebook line by line the way we were the book and kind of do it exactly how he was doing it, or what are you thinking?
Yeah, that's what I'm suggesting. But like, we would still like not like it's not like we would like just blindly follow him. We would also still try to use our knowledge and our heads to like see like what we are doing, like observe the results ourselves. Because I want to understand the concept so that I can use those concepts in another project. I don't want to like just learn the commands and like the steps exactly like what he has done. I want to like just understand why he's doing that. So that's something.
Does he explain why he's doing them?
Yeah, I mean, I think he's giving like the description for all the actions which he's doing. So he's also giving his observations and what he saw, what he noticed from through the visualization. So that's something which he's doing.
Mm-hmm.
Mm.
Yeah, I like it. I think we'll learn a lot more this way than if we just wing it. Though, don't get me wrong. I think that it's nice to like think through everything on your own and try your best. That's the whole reason we do the data structure algorithm competitions, and then we like share solutions later. Because it is nice to challenge yourself and see what you could come up with yourself, and then look at a solution like this. Like, what did we miss? You know, I feel like you learn a lot more that way, but I'm totally down for this too because this looks good.
I mean, the
So
reason. Yeah, go on. Joe.
the first few new features that he's deriving, trip durations by time intervals, is sort of looking at the generative process. People want to get places in New York. It's looking at the generative process in terms of offered demand during a weekday when people go to the office. What kinds of demands are placed on the taxi cab service, and on a weekend it may be different. People are going to leisure activities. The next few features that he derived are looking at the SUT, the system under test, which is the transportation network, and it's asking, fine, given some offered load, some demand that was placed on the SUT, what was that system's response? Essentially, it's asking about traffic. Is traffic bad at noon or midnight? Is traffic interesting on weekday versus weekend, that kind of thing?
So the trip duration per hour, per weekday, month is kind of looking at the demand. Which ones are looking at the, what's the second one you mentioned?
That's correct.
Rest?
And then especially speed per hour or speed per weekday is looking at, given that someone wanted to go through the transportation network, what shape was the transportation network in? What did the city streets look like at a certain hour or on a certain weekday? Was it able to quickly deliver transportation services, or was there a lot of traffic congestion? And so we see very low speeds.
Mm-hmm.
Yeah, traffic congestion is something which even like I was able to infer based on why he's doing that, because if you get like the total number of trips during that particular month or hour or weekday, that could like give you like better insights on like how are the traffic congestions and how like would it like affect the trip duration. So yeah, that something was like very insightful.
Mm-hmm. Yeah, that makes sense. That's interesting how he thought through the demand. Though yeah, I wonder, because he came up with this thing like, how do you measure traffic? You know, like that must have came across his mind too. Like, traffic must be a super important thing to know. But how do you use the attributes given to measure traffic? So is there any, like, is that part of the process? Like, what are the most important features that we could come up with? Like, what's the most important information for this problem? And then try to create that information based on the data you were given?
That's a good question. So what are the variable inputs in this system in order to get the results we want? Or you could imagine, if after you finish building this whole system, how would you advertise it to the consumer? By consumer, I would mean like Uber or one of these companies that deal with transportation. Even the bus system in every city could use this program. So what kind of variables would you need to input in the system? Yeah. Seems like speed per hour is one, speed per weekday is one. I would say, I would imagine population density in every city. It should be important. What else? Yeah, how many cars exist?
You know what I noticed he didn't include though is, wait, let me see. Oh yeah, he did.
Include what?
Just pick up and drop off locations. Oh yeah, look at that.
Cool.
Wow. Yeah, that's clearly Manhattan. Wow. Oh, yep. Yeah, he did a good job. These are the drop-off locations.
Yeah, I think there was this one point which John raised regarding the trips from or to airport. So that could like add up a long trail. So he has mentioned that point as well, I think, where like there are some trips because yeah, like the maximum population is within like the Manhattan area, but there are some trips which basically goes beyond Manhattan, and that could be like something like to and from the airport. So he has mentioned that as well. So that was like a good insight.
Hmm. Yeah, wow. Okay, so he broke it down and then the months to pickup hour. And then he broke up the pickup hours between the full 24 hours. Huh. Wow, yeah, he's really breaking up the data very well. And then it looks like the max passenger count was 9. He broke it up into, wow. Yeah, this is impressive. Yeah, we could work through it and just kind of like type it out as we go along, if that's is that what you were trying to do, Aditya? And then, I mean, we have the Jupyter Notebook, so we kind of have what we've been working on anyways. But this is definitely very, very thorough.
Yeah, I mean, the reason I'm thinking of this notebook is because this notebook kind of like builds almost all the concepts which we would need if we like go for like a different another project, because EDA is something which you would need it for like not just regression but even classification models. So I just want to be like thorough with like the EDA part, and that's the only goal which I have. Like, because model and all I can learn later about like how to build as we go ahead with the chapters. But EDA is something which is like the base for literally every model. And I feel like this notebook would give us like a better understanding of what libraries, what functions we need to use, like, and how we come up with like the feature selection, the feature engineering process.
Mm-hmm, mm-hmm. Yeah, I love the way that he broke it down to such a granular level. I really like that. All right, cool. So we'll start moving through. Is there a particular place you wanted to start at, or what were you thinking? Just want to get all these libraries in.
I mean, I was just like thinking of going through every like every uh, code snippet which he has done, and try to like these models, these live imports, we can do it like later, but like just understanding every concept what he has done. And like we don't exactly have to do everything, but we could like go through it and like try to understand like why he has done that. And I'm like also trying to like make a note of, like, for my understanding, like just make a note of what are the EDA, like the stages which he has used EDA, and what libraries and what functions and what all visualizations which he has used to understand the data for that particular factor in EDA. So that's something which I want to like see.
All right, I'm down for that. That makes sense. I mean, looking at this stuff that he's doing in the beginning with the data head, this is all stuff that we sort of went through anyways to begin. Just looking at the head of the data. We already did that. Feature details. Yeah, so we already analyzed this stuff here. Data shape. We didn't do this one here. But this is just to give you like a big picture. Yeah. This is the number of rows we have. This is the number of columns we have. Approximately 1.5 million records in the data set. We did is null.sum. All right, so this is checking for the attributes that are missing from certain roles, right?
Yeah, it is just trying to see if there are any null values.
Yeah, so in our first data set with the real estate properties, there was one category, there was one attribute that had like a ton of missing values. So this is just saying there's no missing values in our data set.
Correct.
Yep, yep. Okay, cool. So there's not a number or null record in the data set, so we don't have to impute any record. All right, so that's good. What do we got here? Convert timestamp to date time format to fetch the other details as listed below. Pick up date time. Okay, so this is just converting it to a numerical format instead of the object, right?
I think he said 2 date time. I'm not sure if it's like he's converting it into like, I think it's converting just into like date format, like month, like Feb something, Feb year, or like something like that.
Which is still SRs, and it's
You're breaking up.
to a date time object.
Yeah, combines a date time. Year, month, day, hour, minute, milliseconds. Okay, cool. So just creating a different type of object. Who was that just trying to talk? You were super choppy. Was that JH?
That's right.
Yeah, you were. I didn't hear anything you said. It was very choppy. I heard that response though. So then calculate and assign new columns to the data frame, such as weekday, month, and pickup hour, which will help us gain more insights from the data. So we're basically using these date objects we just created to create a weekday attribute, a month attribute, a weekday number attribute, and a pickup hour. So pickup date time, DT. Oh, date time, weekday. Okay, so this is basically just categorizing them by weekday name, by month, by weekday, by hour. It must be so nice already knowing and understanding Python libraries where you know all the functionality that you could just use already. We'll get there. I'll get there. I'll speak for myself. I'm sure a couple people here already got that stuff. All right, and then does anyone want to add anything here? I'm just trying to go through and understand all this stuff, but feel free to chime in.
What was the last one you just said?
This one here.
Yeah, the point, I was just looking at the thing there. The point of what he did with the date time and all that is to take the date, you know, what the field was, which may have been a string, and turn it into a date time so that he could call the functions on at the site. Now, here's the day, here's the month, here's the year.
Mm-hmm. Yep. Yeah, just adding attributes. All right, and then calculate distance. Is this similar to the distance function that you came up with, JH, or more like the ones we did yesterday, Aditya?
This is Haversian distance. I'm not sure if what we did was exactly, because it's same. It's basically covering the distance across a sphere. So I think what we did was, I think that also uses, like, that is also the distance across a sphere, as far as what I understood. But this also is the same. It's just a different function, I think, which is using.
So it's not from pickup to drop off. It's not from pickup to a centralized. Yeah.
It's not a straight line. It's basic. It's basic because straight line doesn't make sense. That would be like within the sphere.
Yeah, I meant more so, is it the distance formula that calculates from a centralized location or from the actual pickup to the actual destination? It looks like pickup to drop off. So
Yeah, he calculated the distance from pickup to drop off. But like the function, which is like the generic function, is like our function, and what his function, I think they are doing the same work.
Cool. Calculate, data apply, calculate distance. So basically calculating the distance for every row, essentially, to create that new distance attribute. Calculating a new speed attribute with the distance divided by trip duration divided by 3600. So miles an hour. or meters an hour, depending on calculated the distance. Haversine, I don't know if that goes to meters or miles, but it would make more sense if it was meters or kilometers. Data, D types, reset index. All right, so then he's taking a look at the new attributes. How much did we start off with? 10, right? No, 11. So he just added 6. Okay. Clear enough. Dumbify all the categorical features like store and forward flag, vendor ID, month, weekday number, pickup hour, passenger count, except the label trip duration. So get dummies, prefix flag, dummy drop. I don't know what this is doing here. Dummy drop.
He's basically I think dummies is like it creates one hot encoding. So it is up. So that is a categorical variable, right? N and F, N and basically Y. So he's converting it into like one hot encoding, like numeric values, like binaries. So that's what dummies is doing.
So all of these are going to be values from -1 to 1 or 0 to 1 or.
I think it would be like 0 and 1s, like in binaries. He's converting that flags into binaries.
Okay.
So yeah, that's what he's doing. Like.
Okay, that makes sense. Cool. So basically turning the categorical data into numerical data. And then he looks at the data head again. Just making sure everything was added. Yeah, you're right, 0s and 1s. I didn't see him add the passenger count and the rest of this stuff. Still though, I didn't see him break it down though. I didn't see him break down the How did this stuff get added here?
He did add it, right? I think. So I think he did add like the, not, it should be down only somewhere.
Nah, he didn't do it yet. Yeah, because here, got these, pick up, drop
Well,
off.
does the dummy section do it?
No, the dummy section just converts the categorical data.
Yeah. No, the dummies only did that. You can see in dummy, the passenger count, I think it only created probably. Yeah.
Oh yeah, there we go. Prefix. All
Yeah,
right,
and
so
then he's
get dummy. So
concatenating those
it takes data dot passenger count and creates a bunch of different attributes with a prefix of passenger count, data column 0, axis in place true, data with dummy concat. Yeah, so dummies, data passenger count. All right, so I'm guessing that this takes, let's just say for every row that has 1 as a passenger count, it creates a row. For every one that has 2, it creates a new column. Then if it has 3, then it creates a new column. And yeah, so it creates a new column for each of the different options in the categories, each of the different categorical options. So if this one has 9 categorical options, like 1, 2, 3, 4, 5, 6, 7, 8, 9, then it'll create one column for each different option. So you can see pickup hour is gonna be, there's gonna be 24 buckets, right? So yeah, 0 to 23. And then weekday number, we have 7, depending on the day of the week. And then month, obviously, is going to be 0 through 11. Actually, looks like there's only 1, 2, 3, 4, 5. Probably because this data was collected in a 5-month time frame, right?
Which one?
The month. Month 2, month 3, month 4, month 5, month 6.
I think this is that. I think Jan, Feb, March. I think it's that. I think.
That's what I'm saying, but this data set is only from like a 5-month period. Otherwise, there wouldn't just be 5 months, there would be 12 months.
Probably like for other months there wasn't anything.
Yeah, yeah.
What's the avoid dummy trap? What's the column that is dropping?
Yeah, there he's dropping one column. I think in dummies.
The 0 index 1.
What is the dummy trap?
Yeah, I feel like it would be, I'm trying to like type all those and then like see all that data what exactly he's doing. That would be clear rather than, because like he's not like printing every thing which he has done. He's just basically printing the final result of that particular code section.
Yeah. Yeah, no, I get it. I get
don't
it.
know what the.
Go ahead.
I do not know what the trap is, but suppose you have 3 categories. You really only need 2 dummy columns, 2 indicator variable columns, because the third is implicit. If we know that there's 0 in the first, 0 in the second, then clearly there's a 1 in the third. It must be the leftover category, right? So maybe that's what he's talking about.
Mm-hmm. Yeah, weekday 1, 2, 3, 4, 5, 6. Yeah, so it's not including the 7th. It's not including the 7th day. Huh. Yeah. Interesting. Looks like the dummy trap, also known as the dummy variable trap, occurs in machine learning and statistics when using dummy variables, also known as one-hot encoding. So Aditya, you were spot on with that, to represent categorical data. Dummy variables are binary, 0 or 1, columns created for each level of a categorical variable except for one level, which is left out as a reference group. The dummy trap is a situation of multi-collinearity that arises when these dummy variables are highly correlated. Severe independent variables in a model. Several independent variables in a model are correlated. 2 variables are considered perfectly collinear if their correlation coefficient is 1. Oh, okay. Does anyone know how to break this down in like simple terms based on this little search that I did? Otherwise, we could keep it pushing. I was just curious.
What multicollinearity?
Yeah, it says the dummy trap is a situation of multi-collinearity that arises when these dummy variables are highly correlated.
I think collinearity is mostly like how, like if there is like collinearity within like some kind of high correlation within the feature. I think it's more about like giving a direction or something. What is collinearity?
Okay, that makes sense. This is saying, for example, yeah, JH was spot on. For example, if you have categorical variable color with 3 values, red, green, and blue, you would create 2 dummy variables for red and green. Blue would be represented by the situation where both dummy variables are 0. So in the case where, in our situation, in the case where like we have month 2, 3, 4, 5, and 6, if they're all 0, then that would represent the first month. Yeah, okay, that makes sense. Cool. So univariate analysis is the analysis of one variable. Its major purpose is to describe patterns in the data consisting of a single variable. Okay. Easy enough. New York City taxi passenger limit says a maximum of 4 passengers can ride in traditional cabs. There are also 5 passenger cabs that look more like minivans. A child under 7 is allowed to sit on a passenger's lap and rear seat in addition to passenger limit. Damn, so this guy's actually digging into the taxi laws, which is interesting. Yeah, because there's laws surrounding number of passengers, so that's interesting. So in total, we assume that maximum 6 passenger can board the New York taxi, 5 adult plus 1 minor. So options, display, float format, data, passenger, count values. So most of them are 1 count. All right. So 1, 2, 3, 4, 5, 6, 0. All right, so these ones are just not possible, right? And then we're plotting this, so figure size. Does anyone know what this represents here?
Just to go up for a second, didn't he say there was a 7-person possibility?
No, 6.
And
5
then-
adults, 1 child.
I thought they said there were some vans have 7 people.
A child under 7.
Oh, child under 7.
Yeah.
Okay. Oh, well.
Yeah, so these would be invalid, or I don't know what the word would be, but
It might be invalid according to the law. It doesn't mean that they didn't squeeze people in. But I guess, well, what's recording the number of people? I guess if the cabbie is not going to report like his violation of the law if that's going to get him in big trouble.
True.
But
Well,
he
true.
He might do it if he gets more money.
Yeah, but if he's sidestepping the law, he's not going to enter that there was 9 passengers, because then he's reporting himself.
Well, are you saying these are invalid data or?
That's my guess, but I'm just guessing. I wasn't.
I mean, the other way to look at it is there's so few of them that whether they are true or not, it can be outside of what we look at.
Mm-hmm.
What if these data would be like some kind of noise being just added to the main data set, so that like, because yeah, I mean, you could say that these situations would be possible in real world scenario, that like 7 people just like squeeze into a cab.
Mm-hmm.
And like that could be, but what if like the other parameters of these records would be like kind of like noise, or like just to add some noise to the data? It could be that way as well, right?
Why would they do that?
I'm not sure, like it's part of a competition, so
Mm.
And
I'm just like assuming, like I'm not saying like it's the case.
and it's interesting that there's more 5-person trips than there are 3-person trips. If you had asked me what I would guess, I guessed them, in order, but that's not the case. Is that a 0 there?
Yeah. See, yeah, there is a trip with 0 passengers as well.
Well, that could be. You say, hey, come go bring me my takeout order and
Yeah.
deliver to me. I don't know.
Yeah, but we're talking about traditional taxi. We're not talking about Uber Eats.
Hmm.
I wonder who would actually insert the noise in the data, though. I'm just going to do a quick little search before we keep on going. Alright. Cool. And then I don't know what's going on here. Does anyone know about this here?
Yeah, it's basically how the passenger, like how the number of records are kind of distributed across the passenger count. So, like if you like infer from this, you could say like maximum, like most of the passenger count is within like 0 to 4, and the other elements are 0 to 5 or something, and the others are like kind of like skewed. So it's basically gives you like a horizontal distribution, kind of.
Yeah. Okay. Cool. So most of them are 1 or 2, and then the majority are in between 0 and 3, with all the rest coming down 4 plus. Cool. So there are some trips with 0 passenger count. Few trips consisted of even 7, 8, or 9 passengers. Clear outliers and pointers to data inconsistency. Most of trip consist of passenger either 1 or 2. Passenger count is a driver entered value. Okay, yeah. Since the trip is not possible without passengers, it is evident that the driver forgot to enter the value for the trips with 0 passenger count. Let's analyze the passenger count distribution further to make it consistent for further analysis. Oh, okay. That makes total sense. It's evident that the driver forgot. Or they started a trip when there wasn't really a trip. Data passenger count described. So we have the total count, the mean. So the average is 1.6, standard deviation 1.31, and then max is 9. As per above details, mean, median, and mode are all approximately equal to 1. So we could replace the 0 passenger count with 1. All right. So for every row where it's a 0, they're just gonna replace it with 1 entirely. What if it wasn't? What if the mean, median, and mode are all. Oh, this is the median.
I mean, it's basically checking it's more like the maximum amount of like the count, I think. Like 0 is kind of like not covering, I think, probably the 0 count, and that's why he's like kind of neglecting 0 as just changing it to 1, because that 0 could be like an error from the driver. So he's trying to like just, and the like if you change it to 1, I think it's like probably that it's not going to affect the distribution much, and that's the reason he's just changing it to 1, probably. I'm not sure. It's like he's just ensuring that if he changed something, it shouldn't affect the existing distribution.
So
I would call that imputing using the mode. The mode is the most commonly seen count, in this case 1. And so he's saying, well, if we know nothing about the count because, you know, the driver messed up, then you may as well just pick the most likely. You might as well pick the mode, and that's 1 in this case.
Yeah, yeah, that makes sense. So also you'll remove the records with passenger count 7, 8, 9 as they are extreme values and looks very odd to be occupied in a taxi. Okay, wow. So data passenger count only negative or less than or equal to 6. So the 7, 8, 9 we're removing, which is honest 5 records. That makes sense. Okay, cool. And then 60 were converted to 1. Okay, so we end up getting our value counts again, and that looks good. Now everything is 1 through 6. Cool.
And you could see like the distribution is also not like super like it's not like highly ununiform. Like there is a certain like a significant amount to every passenger count. I think probably that's something which mattered when you would be training the model.
Yeah. So now the data is consistent with respect to the passenger count. Let's take a look at the distribution with the graph below. All right. Cool. It's evident that most of the trips was taken by a single passenger, and that is in line with our day-to-day observations. Vendor. Here we analyze taxi data for the 2 vendors, which are listed as 1 and 2 in the data set. So we just do SNS, count plot, data vendor ID, plot show. Looks like most of them are vendor 2, though both the vendors seem to have almost equal market share, but vendor 2 is evidently more famous among the population as per the above graph. Cool. Distance. Let's now have a look on the distribution of the distance across the different types of rides. So data.distance.describe. And the distance is kilometers, right? Mean 3.4, standard deviation 4.3. And then most of them are within like 1.25 miles, 2 miles, or 2 kilometers, 3.88. And then the max, 1240. So you could see here.
Yeah, that 1240 seems to be like an outlier because like if you see the box plot as well, like it's kind of like densely distributed within like 0 to like 100, and that like the 1240 and like even like something in between like around 900, that's like kind of like not it's not like it doesn't have like a pretty good dense in there. So if you see like the 0 to 100 has like highly like the maximum population like.
Yep. There are some trips with over 100-kilometer distance. Some of the trips distance value is 0 kilometers. True. Look at all this here. 0 kilometers. Mean distance traveled is approximately 3.5 kilometers. So 3.44. Standard deviation of 4.3, which shows that most of the trips are limited to the range of 1 to 10 kilometers. And then there are 5,895 trip records with 0 kilometer distance. So data distance equals 0. Head. So he's just going to look at the head of the ones with 0 distance. I wonder if there's anything that stands out. Clearly it's not just 1 kilometer or 0. It's definitely not 0, otherwise they just walk. Oh yeah, distance 0. around 6,000 trip records with distance equal to 0. Below are some possible explanation for such records. So it's almost like he wants to come up with an explanation for every single one too. Customer changed mind and canceled the journey just after accepting it. That makes sense. Software didn't record drop-off location properly, due to which drop-off location is the same as the pickup location. Okay. Issue with GPS tracker while the journey is being finished. Driver canceled the trip just after accepting it due to some reason, so the trip couldn't start, or some other issue with the software itself, which a technical guy can explain. But we do have durations here. I mean, if you look at most of them, there are trip durations, so they, except this one might have just been canceled right away. Yeah, so there's some serious inconsistencies in the data where drop-off location is same as the pickup location. We can't think of imputing the distance values considering a correlation with the duration, because the drop-off location coordinates would not be in line with the distance otherwise. We'll look more into it in bivariate analysis with the trip duration.
Yeah, that's basically just like understanding how the other parameters are in relation with the trip duration, basically. That's what bivariate analysis is.
Okay.
Like if how those two are like correlated, basically.
Yeah, okay. So then we do the distance group by so 0 to 10. From the above observation, it's evident that most of the rides are completed between 1 to 10 kilometers, with some of the rides with distances between 10 to 30 kilometers. Other slabs bars are not visible because the number of trips are very less as compared to these slabs. Alright, so yeah, that's the bulk of the stuff there. And this is still just all this stuff is distance, right? Okay, cool. I love this report. It's so good. Trip duration. So trip duration, describe. Average trip duration, standard deviation, max. So, wow, yeah, look at this. Most of them are just in a very, very small spot. So he seems to do a box plot for all these things that he's going through, which is interesting.
Yeah, boxplot gives you a better view to the distribution of the data across the variable.
Yeah. So it shows you clearly where the outliers are too.
Yeah.
Cool. Some trip durations are over 100,000 seconds, which are clear outliers and should be removed. Yeah. There are some durations with as low as 1 second. Yeah, true. Which points towards trips with 0 kilometers distance. Major trip durations took between 10 to 30 minutes to complete. Mean and mode are not the same, which shows that trip duration distribution is skewed towards right. Mean and mode. What's the mode on here? This is the median, right? This is the mean.
So the mode is the most common figure, and for a continuous distribution, it's a little bit difficult to define the mode, because for a truly continuous variable, we might think of each observation as being closed by a very small random epsilon. But here, the mode has to be pretty far on the left, because that's where all the density is.
Yeah, that's what it looks like.
Yeah, mode is basically just the maximum frequency of a particular value in the set, right?
That's what it sounds like.
Yeah, so think about a continuous distribution that is a mixture of Gaussian. That is, we're adding one normal distribution to another normal distribution. It looks like two humps on the back of a camel. And to find the mean, quite likely it's going to appear in between the humps. So it'll appear at a relative low spot. But the mode is simply which of the humps is taller.
That makes sense.
Oh, I see. Okay.
That makes perfect sense. Cool. So trip duration, group by trip duration. Wow. Okay, so we have a couple random durations that are way out here, huh? Most of them are between 1 and 3,600 seconds, and then 3,600 seconds to 7,200 seconds. And then, yeah, you have a ton that are just scattered out here. Then you just have 1839, which that's basically the cutoff, right? Because there's everything else is 0. So we have a cutoff here. Huh. PD cut, NP, arrange 1, max data, 3,600, count, group by, okay.
Each of those is, you know, one hour, basically, right? 1 hour, 2 hours, 3 hours.
Yeah, it cuts it every 3,600. Yep.
And that one with the 1800, that's like 15 hours worth or something.
That's 24 hours, an entire day. Yeah, you can see. So, like, that actually could be possible. You can see his observation, because that's the reason I kind of raised that point, that this cab service is not like a small cab service. It could be like a trip, basically outstation trip, or like basically how you rent a cab for like a day, something. So that could be possible as well.
No, that's not TLC rules. It's not a tariffed fare. A company could own a medallion cab and rent it out, but it wouldn't be able to put it on the meter in that way.
Yeah, that makes
The
sense.
86400 is just a data collection artifact. Sometimes people hit the meter on and they neglect to turn it off, and then it's parked in a garage, you know, for Thursday to Friday, or maybe Friday to Monday, and there was some data collection artifacts introduced in gathering up this data set when they arbitrarily discarded anything longer than a day. And they apparently didn't do that to 100% of the records.
Yeah, possibly, right? Yeah, that is a good.
Cool. So there are some trips with more than 24 hours of travel duration, 86,400 seconds, which might have occurred on weekends or for outstation travels. Major chunk of trips are completed within an interval of 1 hour, with some good numbers of trip durations going above an hour. Let's look at those trips with huge duration. These are outliers and should be removed for the data consistency. So anything over 86,400, and it looks like we're only getting 4, right? Trip duration. Okay, yeah, because we looked at this before when we sorted it by max. Alright, so these trips ran for more than 20 days, which seems unlikely by the distance traveled. All the trips are taken by vendor 1, which points us to the fact that this vendor might allow for much longer trip for outstations. All these trips are either taken on Tuesdays in first month or Saturdays in second month. There might be some relation with the weekday, pickup location, month, and the passenger. Huh. But they fail our purpose of correct prediction and bring inconsistencies in the algorithm calculation. We should get rid of them for the sake of data consistency. Those are black swans. Okay. So data trip duration, only, so overwrite our data with only trips that are less than that. let's visualize the number of trips
You know,
taken in slabs.
one thing, it'd be interesting to like, what's the law say as to how many hours a cabbie can work in a row? Because there probably is some type of law on that.
Yeah,
You know,
it's probably different depending on the state, and then there's probably like federal laws too.
sure, sure. But it'd be interesting to know.
Mm.
It might be, you know, might be less than 24 because people get tired well before that.
Oh, definitely, definitely. They can't. I think it's like 16 or 18 tops. I'm not positive
Hmm.
though, but I'm curious how would that affect the model. Hello.
So you're still on. We're still here, yeah.
Oh yeah, I was asking you like, what do you think as far as
Oh,
like?
no, I was agreeing with your question, and I didn't. I don't know. You know, could be something interesting to look up.
Yeah.
Not that I'm saying we need to do that, but it could be interesting.
No, I'm curious. I was just actually interested in your thought process, like what you were thinking it was going to lead to. But
Well, you know, I was thinking he's leaving in the 24-hour one, those 1800, and I almost expected him to say, you know, cut off before that because it's kind of, you know, is somebody driving for 24 hours straight, or I guess if it's a situation where they can, it's an extraordinary situation where they can, that I don't understand, that maybe they can do that, but
hmm.
the normal way of, you know, getting a cab and a guy's driving for you, he can't he can't be driving for 24 hours straight, and that, you know, that'd be legal, I wouldn't think.
Yeah, probably. Yeah, I think it's like 18 or 16. I'm not positive though. Um, all right, and then so he does the visualize the number of trips taken in slabs, 0 to 10, 10 to 30, and increasing. So there we go. So this is 0 to 10 minutes, 10 to 20, 20 to 30, and yeah, that looks consistent. We can observe that most of the trips took 0 to 30 minutes to complete, approximately 1800 seconds. Let's move ahead to the next feature. I like how he really like understands each feature, and he makes sure that the consistency in each feature, that there's consistency in each feature. That's really, I like it. I like it. That's like what's really stepping out to me as far as we start going through this. I'm like, I just want to take one or two big insights from going through this, and the first one for me is just that first, create as many different attributes that may be useful as possible, and then second, make sure that the data is consistent within each attribute, and just go through them one by one and visualize them one by one in the way that is best for this type of data. So that's what I'm taking from this. Does anyone else have anything they want to add to like insights they're gaining from this as we move through it, or anything else?
Uh, there's one thing that I thought was interesting. I looked up. I thought to myself, is there an API where you can send in the latitude, longitude, and it'll give you the like the map, the actual driving distance. And there is, you know, Google has one, and then some other outfit has one. And I didn't try it because, you know, you have to get the key, and then if they may charge money, and so I don't know if it's like economically or time wise feasible to do. But if you had infinite, you know, computing and money and all of that, you could put the coordinates into the API that that does respect how the roads work, and then you could get a better idea of the distance. So that's interesting to think about. And it's interesting to think about, well, if we couldn't do all, a million records, would it help at all to do, a portion of them? Or would it not really add anything? I don't know. But that's something to look at.
Yeah, that's a good question. Let me know if you find anything out about that. Anyone else?
Yeah, I actually, one thing which kind of I caught my eye was like the way he's like uh breaking down the breaking down each feature into like intervals and sections, especially when he works with time. So like that's something which like there are a lot of projects which are like time series based, like continuous data. So the way he's breaking down the continuous data, I feel like that's a really good insight for me, because that's something like helps you to understand, like kind of convert a continuous factor into a discrete factor. So the way he's doing that is really good.
Mm-hmm. True. True, true. It makes me think about how else would you cut up data to a granular level like this if it's not time, if it's like something else, you know? Speed. Speed is a function of distance and time. Let's visualize speed in different trips. Maximum speed limit in New York City is as follows: 25 miles per hour in urban area, so 40 kilometers an hour, 65 miles per hour on controlled state highways, so 104 kilometers per hour. Though no one follows those. Mean, so the average is 14.42, standard deviation 14.98, and median is 12.79. And then yeah, so it looks like most is from 0 to maybe 1500 kilometers per hour, which is 1500. That's not even, yeah. So 1500, even that's kind of fast. And then clearly this is just not true. Many trips were done at a speed of over 200 kilometers per hour going supersonic. Let's remove them and focus on trips which were done in less than 104 kilometers per hour as per the speed limits. Okay. So speed, most of the speeds are happening between 0 and about 30. And then it still looks pretty dense up to here too, though. Trips over 30 kilometers per hour are being considered as outliers, but we cannot ignore them because they are well under the highest speed limit of 104 kilometers per hour on state-controlled highways. Most trips are... Okay, so basically anything right of this line is an outlier. But that doesn't mean that they shouldn't be considered as long as it's within the constraints of, like, law or other things. What else besides law? If you want to chime in, let me know. Mostly trips are done at a speed range of 10 to 20 kilometers per hour with an average speed of around 14 kilometers per hour. Let's take a look at the speed range.
So think about why that is. If you recall the time analysis, most trips last roughly 15 minutes. And you honestly don't have time to get to a major interstate if you only have a few minutes to go through city blocks, then hit the interstate, and then you're back on city blocks to get to the last mile.
Mm-hmm. True. True. Though you could go from a city block to a highway real quick in New York City. So that's probably these ones, right?
Yeah. Well, so having a long distance between the pickup and drop off lat long implies a long duration, more than 20 minutes, and also implies high speed.
Yeah, true.
You know, it makes sense when I think about the 14 or 15. Like, imagine it's a high traffic zone. Like, how fast do you go when you're driving down a block where you know at the end of it you have to stop, you know, whether there's a light or you have to watch for the other cars flying by. You know, 15 would be about the speed you'd go down at.
Speak for yourself. I do a buck 50. I do a buck 50, bro. I'm just playing. I'm just playing. Yeah, that makes sense. So trips over 30 kilometers are being... okay, I already read that. Let's take a look at the speed range distribution with the help of a graph. So, okay, most people are traveling between 10 and 20 kilometers per hour for the most part. But actually most trips are 0 to 30 kilometers per hour, with these ones here likely being the longer range ones, right? It's evident from this graph what we thought off earlier. Most of the trips were done at a speed of 10 to 20. Store and forward flag. He ended up normalizing this data so you could see. This flag indicates whether the trip record was held in vehicle memory before sending to the vendor, because the vehicle did not have a connection to the server. Yeah, this is good because I was more curious about this, so I'm curious what he has to say about this. Above results show that only about 1% of the trip details were stored in the vehicle first before sending it to the server. This might have occurred because of the following reasons. Outstation trips didn't have proper connection at the time when trip completes. Temporary loss of signals while the trip was about to finish. Inconsistent signal reception over the trip duration. The GPS or mobile device battery was down when the trip finished. Okay, above results, and this is just checking the value counts. Above results show that around 8,000 trips had to store the flag and then report to the server. Then when the connection was established. Let's check the respective distribution with the vendors for the offline trips. Wow, so it was all just one vendor, huh? Flag, yes. Above result shows that all the offline trips were taken by vendor 1. We already know that vendor 2 has greater market share compared to vendor 1, so there could be 2 reasons for this scenario. Either vendor 1 utilizes advanced technology, then vendor 2 to store and forward trip details in case of temporary signal loss. Huh. That makes sense. Or vendor 1 uses poor infrastructure, which often suffers from the server connection instability, due to which they have to store the trip info in the vehicle and send it to the server later when the server connection is back. Let's check if there's some relation.
Or it could be that vendor 2 simply never implemented the store and forwards.
Yeah. That's this one though, right? Oh, you're saying that it's technology they both have, but vendor 2 just chose not to use it?
Yeah.
Yeah.
I mean, you see this all the time when specifications go through several revisions, and think about Wi-Fi, and a Wi-Fi router implements this or that. Maybe the vendor didn't get around to adding a feature, or maybe they released their software the year before a new specification came out, and that explains why they don't implement that feature.
Yeah.
And if they don't implement it, then there's 0 observations of that feature.
True. So then he goes on to show all of the data for the yes flag, which is a lot. Some trips are local, some cover longer distances. Almost each day is listed against offline trips. Offline trips were taken almost at all hours as per the search result. There is no month which appears to be more dominant in the results, and even the trip duration covers different scales. So all in all, there doesn't seem to be any relation with either of the metric for the offline trips. Let's move ahead. So he just keeps that data in. He doesn't change it at all. The only thing he did was normalize it. Trips per hour. Let's take a look at the distribution of the pickups across the 24-hour scale. So count plot data pickup hour. Plot show. And this is just going to take the
it's the
prefix.
city that never sleeps.
I know, right? People are sleeping at 4 or 5. What the heck? So if I do data.pickup hour, it's just going to take everything from with the pickup hour prefix.
Yeah, I mean, you created that pickup hour column, right, in the data.
Pickup hour.
So when you,
Oh, yeah.
you created that. So when we did that date time conversion, so it's part of that data set.
It's in line with the general trend of taxi pickups, which starts increasing from 6 a.m. in the morning and then declines from late evening around 8 p.m. There is no unusual behavior here. Looks about right. And then it dies down after midnight. Total trips per weekday. Let's take a look at the distribution of taxi pickups across the week. Okay. This looks like busy every single day. At least 170,000 every day. Here we can see an increasing trend of taxi pickups starting from Monday till Friday. The trend starts declining from Saturday till Monday, which is normal, where some office going people like to stay home for the rest of the weekend. Let's drill down more to see the hour-wise pickup patterns across the week. Ah, okay, I like this. So he actually broke it down not only by day, but also by the hour of each day, which is interesting. Yeah, because you get the weekend and you don't see the same peaks you see.
I feel like what he's trying to do more is not just focus on what is needed for the prediction, that is trip duration, but he's trying to like understand that what all insights we can gather just from this data set, so that we could come up with some other business insights which would help like build like more models basically. I mean, that's how it works in real world as well, right? When you're working in a company, when you're building a model, you have been given the data, but it's not like you have to like just do like just one particular model. Like you basically are given a data, you could like understand the data and come up with like business decisions for like literally every feature.
True. Yeah. So so you're saying he's exploring the data not just to create the model, but to gain business insights.
Yeah, he's actually like completely opening up the data to understand each and every feature as to like what insights they give. So I think this project is not just about like prediction, but it's like pure EDA basically, exploratory data analysis. That's what he's doing on the data set.
Yeah, that's interesting.
So I'd like to comment on the binning. If you look, for example, at the first three, I guess that's Sunday, Monday, Tuesday, they have sort of a similar shape, right? Even into Wednesday. But then we see a radical change along about Friday, Saturday. Can anyone offer an explanation as to why there's such a big change?
Just people going out at night. Shows.
I mean, in weekends, the night cabs would be more, right? Like, I mean, like short cabs.
Oh, are the last two are the last two weekend?
No, I think it's just Saturday. Like 0, 1, 2. Oh yeah, last two I think seems to be weekend. Yeah.
Yeah, I think the last two is Saturday and Sunday. So you see like the spike in the beginning of Saturday and the spike in the beginning of Sunday. That's like Friday night and Saturday night.
Is that what it says on the in the tiny text? Because I was thinking Sunday is usually counted as day one
It just
or day
says it just
zero.
says weekday, but based on what he said previously, where it starts increasing on Monday and then decreasing on the weekend, he said that this starts with Monday. So you can see here we can see an increasing trend of taxi pickups starting from Monday till Friday. So Monday till Friday, the trend starts declining from Saturday till Monday, which is normal. So Saturday till
Hmm.
Monday.
I mean, usually I feel like it's more about like Friday nights and Saturday nights. So you would see like those days where like uh, like you can see like at the 0th hour, like if you go down to that bins, you can see at the 0th hour, which is usually like 12 a.m. I think. So you can see for like weekdays you won't see that spike,
Yeah, here and
but
here.
for like weekends you will see that spike. But yeah, so that's something which like describes, I think it's because like those Friday nights and Saturday nights probably.
Yeah, this is Friday, this is Saturday. So you'll see Friday night spikes into Saturday morning, and then Saturday night into Sunday morning, midnight. Yeah, because Friday's the busiest day of the week, clearly, because that's the one day of the week where people are still going to work and they're going out.
So here's my complaint about that binning. We've got 24 hours. The natural number of bins to use would have been 24, but there's only 10 bins, right?
Mm-hmm.
So you have to worry about sort of round off error and spillage from one bin to an adjacent bin.
Yeah. So you would have done 24 for each one.
Right.
Yeah. What I wonder what you would gain with 24 that you wouldn't gain from the 10.
So if we have kind of a morning rush and then a lunchtime spike and then an evening rush, and there's a secular rise as the weekdays progress towards Friday, if it's sort of the whole trend is going up over the course of the week, then round off errors where the lunchtime spike might be showing up in bin 5 or bin 6, that can have a big effect as I'm saying that a small change in the world can result in a big visual change.
Mm-hmm.
I basically like, so the thing is like if you consider like a morning time, let's say like around 7 a.m. or 8 a.m., that's usually like a rush time where people leave for their office or like book a cab or something. So obviously like if you consider that that span of that morning rush, I mean it would at least last for like 2 hours, right? Like if you talk
Yeah.
about the lunchtime, that would like go for like next 2 hours or like 3 hours. So I think he's considering that spans, I think. For example, he's considering like that 0 to 2.5 or like 2.5 to 5, 5 to like 7.5 and then 7.5 to 10. I think that kind of bins that's the way of distribution he's considering, I think.
So 7:30 to 10 basically. 7:30 to 10.
I mean, that scale is basically 0 to 5, but you could see there are like that 0 to 5, one single interval is split into two bins. So that basically you could say like one bin cover like 2.5 hours.
Yeah, 2.4 hours, and then
2.
yeah. I think that I would rather see it in 24. I'd rather see it in hour increments just so I could think about it as like each hour of the day. But then I also understand how he's just presenting it small, and that might be harder to even like see like which one is hour 12. I have no clue. This thing is so small. If I pulled it up big like we do on the left here, then that would make sense, because then you have like one big graph 24 across, then you'd be able to actually see the granularity. With small like this though, is like it provides me enough information to get the gist of it. I'm curious like what he's actually doing this for though. Taxi pickups increased in the late night hours over the weekend. Yeah, so here and here.
Well, this is all building up what is traffic at a
True, true.
certain
Yeah, he's
day and
actually
time.
building up the traffic.
Mm-hmm. Mm-hmm. Early morning pickups before 5 a.m. have increased over the weekend. True, true. In comparison to the office hour pickups after 7 a.m., which have decreased due to obvious reasons. True. Taxi pickups seem to be consistent across the week at 15 hours or around 3 p.m. Yeah, that makes sense. Cool. Total trips per month. Then we start diving into this. I'm gonna hop off in just a couple minutes. I have to take off for 7:30. But y'all can hang out and continue exploring this if you want. Like that's totally fine. I'll just catch up, or y'all can fill me in. I'll continue looking through this, but I don't want to like if everybody else wants to continue exploring it. I don't want to be the one to make it end. So you guys could definitely feel free to hang out and continue exploring or discussing or anything. You know.
I also kind of have to hop off for like another work, but like I'm going to actually go through this notebook again and just try to make a note of what all stuff is done like from my end, like kind of like try to run those commands and like functions and like see like what I could like also like try to use in like other projects if I work, because that's something which I want to do like this next week, so that when we'll come like to the next chapter like or something, then that, or like when we'll go through this data set again like next week, I probably would have like better understanding when we'll go even for the next chapter or something.
Mm-hmm, mm-hmm. Yeah, I sort of want to, after we finish this project too, I sort of want to just do a model on my own and just try to create as many different attributes as possible and break it down the way that he's breaking it down, and yeah, just give it a shot, you know?
Yeah, that's what I want to do. Like that's the reason I recommended this notebook, because this helps me to understand like what exactly I need to do with other projects basically.
Yeah. Yeah, because he that's one thing that really pops out to me is he basically expanded the number of attributes before doing any exploration. Like we were kind of expanding. We were kind of like, well, what can we add now? All right, now that we added this, let's explore it. And then we're like, now what can we add? All right, now let's explore that. But he just thought it through in the beginning, or at least that's what it seems like, where he expanded the data set first and then he explored it. It's almost like he knows how to just open it up in cool and interesting ways, and then you have like a much clearer map to explore, you know. So that's what I'm taking from this so far. And then yeah, feel free to continue the convo, and we'll pick up where we left off on Friday. But I'm going to continue exploring it during the week. And if anyone comes across anything, definitely feel free to share it in the machine learning channel. Aditya posted the link here. So this is a really great notebook. I'm going to post it in the machine learning channel just so people have it too. All right. Cool. I'll see y'all sooner than later. Enjoy the rest of your nights.
Okay.
You.